We're going to examine units of data. Units of data are really useful because they are used to measure the size of a file, the storage capacity of a disk, the processing speed of a CPU, and the speed of transfer of data. Now, you should be aware that all data on a computer are stored in binary, and the smallest unit available to us are bits. These are a single binary digit, and they can be either 0 or 1. The next unit up are bytes, and these are made up of 8 bits. We also then have other power of 10 units. So we have the kilobyte, which is 1000 bytes. We have megabytes, which 1 megabyte is equal to 1 million bytes. And we have a gigabyte, which is the same as 1 billion bytes. And then we have terabytes, which is 1 trillion bytes. So they are our power of 10 units. But because power of 2 units are a more suitable measure for binary data, we're going to introduce these now to show how they are able to be used to help us to reduce the ambiguity of, for example, file sizes when we're using power of 2 units compared with power of 10 units. So with power of 2 units, we have the kibibyte. This is 1024 bytes. We have mebibyte, which is just over 1 million bytes. We have the gigabyte, which is 2 to the 30 bytes, and then we have terabyte, which is 2 to the power 40 bytes. So you can see kibibyte is 2 to the 10, mebi is 2 to the 20, gibi is 2 to the 30, tebi is 2 to the power 40. So comparing the power of 10 units and the power of 2 units, you can see there isn't a tremendous difference, for example, between a kilobyte and a kibibyte. But as I've already mentioned, the kibibyte gives us a more precise measure than the kilobyte. We're going to work our way through a few examples that allow us to compare these different units of data. So our first question is to determine how many mebibytes there are in 5 tebibytes. So if 1 mebibyte is equal to 1 times 2 to the 20, so what we're doing is we're converting everything into bytes. 5 tebibytes is 5 times 2 to the 40, and what we do then is we divide the 5 tebibytes by 1 mebibyte, and then when you calculate that, that gives us just over 5 million mebibytes. The next example we're going to look at is to compare 3 million kibibytes with 3 gigabytes. So which of those is the biggest? Again, what we do is we convert everything into bytes, and if we've got 3 million kibibytes, well, that works out to just over 3 billion bytes. And then converting 3 gigabytes into bytes, that works out at also just over 3 billion bytes, but clearly we can see that 3 gigabytes is the biggest of the two. And in the final worked example, we're going to put a sequence of units in the correct order. So we have 2000 kibibytes, we have 2 mebibytes, we have 2 megabytes, and we have 0.2 gigabytes. So 2000 kibibytes is just over 2 million bytes. 2 mebibytes again is just over 2 million bytes. So it's slightly bigger though than 2000 kibibytes. Then we've got 2 megabytes, that's easy, that's 2 million bytes, and then 0.2 gigabytes is 200 million. So when you put those in order, then clearly 0.2 gigabytes is the largest, then we've got 2 megabytes, then we've got 2000 kilobytes, and then we've got 2 megabytes.